Number 3, our a squared is 9, so a is going to be 3. And since we have square root of x squared minus 9, that is going to be a secant substitution, so x is going to equal 3 times secant of theta, which means dx is going to be 3 secant of theta, tangent of theta, d theta. So we're going to go ahead and substitute those in to our integral. So we have square root of 3 secant of theta squared minus 9 all over 3 secant of theta, and then our dx becomes 3 secant theta tangent theta d theta. So right away we can cancel out 3 secant theta here and here, and then try and simplify in here. We're going to end up inside the square root 9 secant squared minus 9, so we can factor that 9 out and we get secant squared of theta minus 1, and then we have our tangent of theta d theta. We can simplify the inside of that square root. That's just going to be square root of 9 times tangent squared of theta times tangent of theta d theta. So we end up with 3 tangent of theta when we take the square root of this times tangent of theta d theta. So we get 3 tangent squared of theta d theta. But we can't evaluate that as is. We could use some of those different identities. So the best way for this one is to go ahead and do 3 times, instead of tangent squared, rewrite that as secant squared of theta minus 1. And we can distribute that 3. We get 3 secant squared of theta minus 3. And we can actually separate this and do each one on its own. 3 secant squared of theta, well, the 3 stays there. Antiderivative of secant squared is just tangent. And then over here, antiderivative of 3 d theta is just going to be 3 theta. So we need to figure out what tangent of theta is and what theta is to finish this problem up. So we're going to use our picture. We've got a triangle. This is our theta. We know x equals 3 secant of theta, so secant of theta equals x over 3, which means cosine of theta would be 3 over x. Those are just reciprocals. So our cosine adjacent is 3, hypotenuse is x. Missing side here is going to be square root of x squared minus 9. We can get that from here. So we need tangent of theta. Tangent of theta, opposite over adjacent, so we have square root of x squared minus 9 all over 3. So when we multiply that by 3, the 3's are going to cancel out for that. And then we need to figure out what theta is. Well, if cosine of theta equals 3 over x, then theta is going to equal the inverse cosine of 3 over x. Or we could do the same thing over here. We could say that theta equals the inverse secant of x over 3. Either one of these would be appropriate. So I'm just going to go ahead and use the cosine one. But if you wrote inverse secant of x over 3, that's going to give us the same thing. So I'm just going to go ahead and erase these two here. And this is our final answer for number 3.